Okay, graphs without equations number 3. The first thing that I see when I look at this problem is that this graph is denoted the graph of f. So we are looking at an original function here, which is a little bit of a twist on what we're used to. So it does say, let's look at the details. Let f be a continuous function defined between -4 and 3, whose graph consisting of 3 line segments and a semicircle. So they are confirming that those are straight lines and that curve right there is half of a circle. So you got to think that that has something to do with it. Let g, they're introducing another function, be the function given by g of x is equal to the integral from 1 to x of f of t. So let's think about this. G is an integral, so we should be thinking it's accumulation of area. That's what you should be thinking before you even start to tackle the parts of this problem. G is an accumulation of the area of f. So let's look at A. A says find the values of g of +2 and g of -2. So g of 2 would be equal to the integral from 1 to 2 of f of t dt. You should always establish that. Always write it down, okay? You never know when you might get partial credit just for setting it up, even if you can't figure it out. But hopefully you could recognize that the integral from 1 to 2 would be the area under the curve from 1 to 2. So this is a triangle. So we've got 1/2 times the base. Well, it's width 1 times the height. That would be -1/2. You got to include the negative because this is under the x-axis, so it's got to be negative area. So we have -1/4 for g of 2. G of -2. So that's the integral from 1 to -2 of f of t dt. Now, me personally, I don't like when my limits are backwards from where they're supposed to be. So I'm going to stick a negative in front of this and flip my limits around so that I don't have to try and think about, okay, well, this is negative area, but because I'm going backwards, it's really positive area. I would rather just look at it left to right and change the sign of everything at the end. Okay, so let's go left to right. Starting at -2, we've got a triangle right there. And we're going until we get to 1. So we've got that triangle that has a height of 3. So don't lose that negative in front of there. The triangle is 1/2 times the base in that width 1 there. Yeah, from -2 to -1 is width 1. Height of 3 plus our semicircle. First of all, the semicircle is under the x-axis. So that's going to be a negative. Pi, well, 1/2, right? Because it's half the circle. 1/2 pi r squared. What's the radius of the circle here? It is 1. So we've got 3/2 minus pi over 2. So we can combine those since they're both over 2, 3 minus pi. And because of that negative, that would be pi minus 3 over 2. When we simplify it. Now, there's nothing that says that you have to simplify that completely. The way that I understand it, technically this answer right here is applicable. But if you keep writing, they keep grading. So keep that in mind as well. So don't get too crazy with the simplifying. Or if you do try and simplify things, make sure that you're very careful with your arithmetic. That you don't mess up something simple and lose that point because you were trying to simplify too much. Okay, and actually, the way that I understand it, no simplification is necessary. So really, that answer right there is acceptable. I know it's not nice and pretty and whatnot like we're used to, but if it's acceptable, you know, why risk losing the point? Okay, let's look at B. Speaking of, we got 1 point for each of those answers. Okay, you get 1 point for that one, you get 1 point for that one. As far as I know, it's all or nothing. You either get 1 point for each. No setup or anything involved there. It's either right or it's wrong. Okay, let's look at B. For each of g prime of negative 3 and g double prime of negative 3, find the value, or state that it does not exist. So let's think about this. G prime of negative 3. G is an integral. So if we take the derivative of an integral, they cancel, but just remember you have to plug in that limit. So the limit was the x, so g prime of negative 3 would be equal to f of negative 3. And so we just get that from the graph. F of negative 3 is right here. That's linear, so that would be at 2. Again, you get 1 point for that. No setup, nothing like that, just 1 point, right or wrong. G double prime of negative 3. Well, if g prime is f, then g double prime would be f prime. So if we're looking at f and we want to know the value of the derivative, remember, don't forget, derivative is the slope of the tangent line. So really we're talking about what's the slope of the line, since that's a line right there. What is the slope of that line? It's positive 1. 1 point for that, right or wrong. Okay, so pretty easy so far, right? 4 points, 4 out of 9, really that's solid, okay? Remember, if you're keeping in mind that you're trying to make a 3, if you get half the multiple choice and half the real response, you are sitting real pretty for that 3, okay? And if you get a little bit more than half of each, then you're looking at a 4 there. So if you can average 4 or 5 out of 9 on every 3 response question, then you're set, okay? Obviously, yeah, you want more in case you mess up somewhere else, but I'm just trying to point out this is a good place to be in for this problem so far. Part C, find the x-coordinate of each point at which the graph of G has a horizontal tangent line. Okay, so let's think about this. G has a horizontal tangent line, so that means it has a maximum or a minimum. So if G has a maximum or a minimum, then G prime is going to equal 0. G prime is equal to F. It says for each of these points, determine whether G has a relative minimum, relative maximum, or neither at that point. So you definitely, as you're thinking of that, you need to write that down. You need to say G prime equals F equals 0. You get 1 point for considering that right there. So let's see where that happens. Where does F equal 0? At -1 and +1. So occurs at x equals -1 and x equals +1. It says we need to identify whether it has a maximum, minimum, or neither. So at -1, what's the change? We're changing from positive to negative, so that means we're changing from increasing to decreasing, so that's a maximum. So that means G has a relative maximum at x equals -1 because G prime equals F changes from positive to negative. At x equals -1. Let's analyze at +1. What's happening at +1? There's no change at +1. So G has neither a maximum or a minimum. Technically that would be north. Minimum at x equals 1 because G prime does not change signs. At x equals +1. Okay, so you get 1 point. I already told you got 1 point for considering G prime equals 0. You get 1 point for stating those two values at -1 and 1, and you get 1 point for your correct explanations here. So if you don't get both explanations correct, or you don't identify them both correctly, then you lose that point there. All right, last part, part D. Between -4 and 3, find all values of x for which the graph of G has a point of inflection. So point of inflection, we're thinking G double prime equals 0. Okay, point of inflection, G double prime equals 0, but let's think about what that is in this context. That is F prime. So where does F prime equal 0? Well, that's where F has a maximum or a minimum. So we're talking at -2, 0, and at 1. So we should say G has a point of inflection at x equals -2, 0, and 1 because G double prime equals F prime changes signs at each of these values. I think you could also say because G double prime equals F prime and F has local maxes and mins at these values. Minimums. There we go. If I can spell minimums here. Okay. So instead of just leaving it at that, I went from the perspective of F has local maxes and mins as opposed to just where F prime changes from increasing to decreasing. So there are several different ways you could explain that one. But you get 1 point for your answer, for your values there, and then 1 point for your explanation.